Hello everyone. In this video, I'll be covering demo problem 1, which will enable us to create bins or buckets for the tornadoes.csv dataset. I'll be using Jupyter Notebook to go through this demo problem. The template notebook file already has outline for this particular demo problem. We know that writing a function to compute median is tricky because we have to deal with all of those odd even number of entry cases. Instead of writing median function, we are going to write a simple function which is going to calculate average tornado speed per year. Let me switch over to Jupyter Notebook. The template notebook file already has the snippet of code which will enable you to read a CSV file into a list of list data structure. Recall that we can invoke process underscore CSV file by passing the CSV file name as argument. So I'm going to say process underscore CSV of tornadoes.csv. Let me capture the return value into a variable called data, and I'm going to display the first 5 rows of data. I can easily do that by using slicing. I'm going to say data of 0:5. Recall that you can ignore the start index position if your start index for your slice is 0. So I'm simply going to say data:5 here. Right, we are able to get the first 5 rows. One of the most common representations for the list of list CSV data structure is that people will take out the header row into a separate variable. How can you do that? You can simply assign header equal to data of 0. What do you do to the rest of the rows then? You'll have to slice to get them out. Let me first go ahead and display header. Looks like we're getting the header row. Your header row is always going to be a single dimensional list because you're dealing with one row. How do you get the rest of the rows? You can again use slicing. So I'm going to say, give me a slice of all the rows from data from index position 1 up until the end. Why am I choosing 1 as my start? Because I want to eliminate the header row here. Let me capture that into a variable called as rows, and I'm going to display the top 5 rows using the same slicing by saying rows of :5 here. Looks like we are getting the expected output. We have 4 columns within tornadoes.csv dataset. The first one is year, the second one is ID, third one is location, fourth one is speed. The next prompt here is asking you to write a function to compute the average speed. Let's go ahead and start writing avg underscore speed function, which is going to take one parameter that's going to be the data. What do we want in order to compute speed? We want to have total of all the tornadoes in the numerator and count of all the tornadoes in the denominator, correct? How do we get each tornado's speed? We'll have to write a for loop for that. That's because the speed column here gives the value of the speed corresponding to every tornado, correct? For now, I'm just going to type the for loop as for row in data, and let me just print row. It is always a good idea to test your for loop before you actually use it for any purpose. So I'm going to invoke the average underscore speed function by passing my rows as argument here. What is rows variable? That's going to be my entire data set, which just represents the rows which contain the data, leaving out the header row. Let me go ahead and execute the current cell. Observe that we are getting the output for each row here. Let me remove the print function call and instead replace that with actual computation. What do we need here? Every iteration of the for loop should extract the value corresponding to the speed column, correct? We can simply do that by saying row of 3 here. Let me go ahead and test the current version. Looks like we are getting the corresponding speeds. What is the problem with the current version? We are hard coding the column index. Somebody who's trying to go through your code will have to go open the dataset file and try to figure out, okay, what is column represented using index position 3 here. Instead of doing this hard coding, I'm going to teach you how to use the header list here to look up the column index corresponding to a particular column name. Recall that index method call as part of the list data structure enables us to obtain the index position corresponding to the value that you pass as argument. So if I want to look up index of the item speed within the list header here, I can simply say header.index and pass speed as argument, correct? Please pay close attention here. You will have to start using the index method call to find the index of a corresponding column starting with project P8. If you don't do this, you'll be losing points. You don't want to unnecessarily go through the resubmission process for this particular hard coding, because it's very simple for you to remember this information. When you hard code the column index position, it makes your code less readable. But now when I say row of header.index of speed, it is very evident that I'm extracting the speed column's value here. Let me go ahead and test the current version. It is working. What do we want to do with the speed here? We want to sum all of those speeds up, correct? Whenever you want to sum something within the for loop, you will have to always define a total variable outside the for loop and initialize that to a 0. Why are we doing that outside the for loop? That's because we want to keep track of a running total for every iteration of the for loop, correct? So what think will happen when I say total plus equal to this particular value here? We are going to run into an error. I want to show you how to read the error stack here. So the error is type error, and in IPython input cell 15, which is this particular cell, we have error in line number 6, correct? Always make sure to go click on view and toggle line numbers whenever you're writing code within your Jupyter notebook file. So line number 6 is avg underscore speed function call. So it's going to take me to the function definition cell, which is cell number 15. We have an error in line number 4. Both my function definition and function call are within the same cell here. What is the problem in line number 4? It is saying unsupported operand types for plus equal to, int and string. Your operator here is plus equal to. It is saying that one of my operands is int and the other one is string. Clearly total is of integer type, so this must be a string, correct? That's how you need to debug your errors that you see as part of your project. Why is this a string? Recall that CSV always is represented using strings within the list of list data structure. So we'll have to take care to perform the correct type conversion. So I'm going to say float just for being safe here in order to convert the speed value into a floating point value. Let's try to run the function call. Looks like right now it's working. So how do you compute average? You're going to simply divide total here by the number of rows. How can you get the number of rows? Recall that you can use the len function for that, and I'm going to say len of data here. What do we want to do with that value? We just want to be able to return it. Whenever you write a function, always think about what sort of input and output you'll have to deal with for that particular function. Let me go ahead and run this cell. I know that this is the correct output. If you were to write this program on your own, you'll be spending some time figuring out whether this is the correct output or not. Let's go through step number 1 next. Step number 1 is going to be about collecting the data into buckets. Eventually, we are going to write a function, but for now, let's just start following the process for binning or bucketization. Recall that you just have to write a simple for loop for that. So I'm going to say for row in rows. Let me just display row for now. Rows is my variable which contains the entire data set. We are going to work with that for now. Looks like we're getting the correct output for the current shell of the for loop. What do we want to do with every iteration of this for loop? We want to look up the year value, correct? Let's say that we want to bucketize by year column just for the beginning here. I'm going to extract the year column corresponding to each row by saying row of not 0, instead header dot index of year. Do not hardcode the column index positions. Let's test it. Looks like it's working. What do we want to do after this? We want to be able to create a dictionary to represent the buckets, correct? Think about where your dictionary needs to be created. That should be outside your for loop. That's because every iteration of your for loop is going to go through one entry within your list of list data structure. You want to deal with all the entries inside your dictionary. So your dictionary definition should be outside the for loop here. I'm going to use the variable as buckets. What do we want to do with each row's year column? We want to check whether that particular year column is a key in the bucket, correct? You can imagine creating keys like 2006 and a value as empty list, and 1996 and a corresponding value as an empty list. What is the problem with this particular buckets dictionary? Well, it is incomplete with respect to the keys, correct? Instead of doing that, we should use the for loop itself to populate the keys within the buckets dictionary here. What do I mean by use the for loop? We'll have to check whether every year column's value is a key as part of the buckets dictionary or not. Unless we go through the entire data set, we cannot be sure as to how many buckets you need to create, correct? So I'm going to get rid of this incomplete initializations for the key value pairs within the buckets dictionary. Instead, we are going to use this for loop here. Let me capture the variable year into a variable year here. Sorry. Let me capture the value of the year column into a variable year here. What do I want to do with that? I want to be able to check whether a key exists within the dictionary with that year, correct? So otherwise, I can check whether this particular year is not a key inside this dictionary. I can do that in two ways. I can say if year not in buckets, or I could say if not year in buckets. Both of those work. I personally prefer if year not in buckets because I think that's more intuitive. What do we want to do if the current year is not a key in buckets dictionary? We want to be able to create a new bucket with it, correct? How do you create a new bucket? You're going to simply say buckets of year is equal to a new list. What would be the else case? That's going to be very simple. A bucket already exists, which means that that particular key is already part of the buckets dictionary here. We can simply say buckets of year and then do something with that, correct? Not an equal to here, do something with that, correct? What is that operation that we want to do within the if condition and within the else part here? We simply want to take the current row, which is given within the row variable, and append that into the list, which is the value corresponding to the key year, correct? Both of those operations are exactly same. So we can kind of get rid of this entire else branch here and do that operation outside the conditional. Whenever you have a common operation that you apply to every branch of your conditional, it makes sense for you to move that outside of your conditional. So I'm simply going to say buckets of year dot append of row. Recall that to add a new entry to a list, you'll have to use the append function call, sorry, method call, my bad. Let's go ahead and execute the current version of this cell. I'm just going to display buckets here. Looks like I have a typo in line number 6. Let me fix that by correcting years to year. Observe that we are now getting a dictionary of list of lists. For 2006, we have one tornado. For 1996, we have a bunch of tornadoes, and so on. This is a complete representation of our entire tornadoes.csv dataset. So how do we take this code and convert that into a function? That's very simple. You just tab align all of that code in. Think about what is going to be input to your function. Let me call my function as bucketize. My input is going to be the column based on which I perform the binning or bucketization. That's going to be year here, correct? So I'm going to define my parameter as bucket underscore column here, and I'll have to replace the hard coding year with bucket underscore column. What do I want to do with the buckets? I want to be able to return it. Let's go ahead and run the function definition here. I'm going to invoke bucketize function to bucketize the data by passing year column as argument. Let me capture the return value into a variable called year underscore buckets, and I'm going to display year underscore buckets in the next line. Observe that we are getting the correct buckets based on year. Now that we have the bucketize function, it is very simple for us to create other buckets based on other columns. Let's try out creating buckets using location column. For location column, we have three unique values, which are site A, site B, and site C. So your buckets dictionary is going to contain those three strings as keys, and the corresponding list of list rows which have that particular value as the values. So you're going to get all the rows which have site B as part of the site B keys list of list value. Let's go through the next step here. Step 2 is asking us to write a function to compute the average speed per bucket. I'm going to define this particular function as avg underscore per underscore bucket, and we want to pass the bucket as argument here, right? Let me define the parameter here as groups so that it's clear that we are talking about groups within the function here. So in order to compute the average speed per bucket, we need an average speed function, which we already wrote at the beginning of this particular demo problem. We also need buckets, which we have via the bucketize function. I'm simply going to combine both of those together here. I'm going to write a for loop to iterate over every bucket. Recall that the for loop over a dictionary returns the key. So I'm going to say bucket underscore name here. For bucket underscore name in groups, I'll have to use the variable groups. What do I want to do with the bucket? For now, let me just print bucket underscore name here. Let's try to invoke the average per bucket function by passing year underscore buckets as argument. The year underscore buckets is going to contain the bucketization based on year, correct? So let me go ahead and run the current cell. Observe that we are getting site A, site B, site C, which is not correct because I used the same variable for location. Let me quickly replace that. I'll have to rerun the previous cell because the next cell's execution overrode the variable here. So now if I execute this, we are going to get the correct output. All right. So when I print bucket underscore name, that displays the bucket key here. I want the value instead to compute the average, correct? The value is the list of list that corresponds to that particular bucket. So how do we compute average? We are simply going to invoke avg underscore speed function. I'll have to pass groups of bucket underscore name as argument, and the return value is simply going to be average for that bucket, correct? For now, let me just print average. Let's try to run the function. Looks like we're getting the average speed for every year here. Wouldn't it be nice if we define another dictionary to keep track of all of these average speeds? Where do you have to create that? You will have to create that outside your for loop. That's because every iteration of your for loop is going to compute the average speed for every bucket. So if you want to keep track of every bucket's average, you'll have to define the averages dictionary outside. So what's going to be the key for my dictionary? That's going to be the bucket name itself. So I'm going to say averages of bucket name, which is going to be the key, equal to value. What's going to be my value? That's the average value that we just computed. So I'm going to go ahead and return averages dictionary from the function. Be careful with the return statement. You do not want your return statement as part of your for loop. That most likely doesn't make any sense because you want to return after going through every iteration of the for loop here. So let's run the current version of the function. Observe that we are getting a dictionary of your bucket name, which is the year, and the average speed corresponding to every year. Bucketization enables you to answer this question very easily. Similarly, we can compute the average tornado speed per location by simply bucketizing based on location and passing that buckets as argument. I'm going to pass locations underscore buckets, and that's going to return the average speed per location bucket here. I'll go ahead and wrap up this lecture video here. I'd like to remind you one more time that you'll need this concept of bucketization for project P8. You can very simply copy paste this entire function into your project P8 code to perform the bucketization. That's a hint for you.